Hello guys, so today we are at day 23 of Leetcode Me challenge. As you can see, today is May 23rd. Oh, it actually take me to the time. That's great. I didn't know that. I accidentally discovered something. So anyway, let's just start with our today's problem. And before I actually do that, just so don't forget to like and subscribe this video. Like this video and subscribe this channel for keep getting the more of such videos and contest. I'll also be streaming the contest tomorrow, so don't forget to subscribe for that. So yeah, without further delay, let's just jump over to the problem we have today. So we are basically given two lists with closed interval. Each list of interval is pairwise, disjoint, and in sorted order. Okay. Now our task is to return the intersection of these two interval lists. So okay, this problem sounds similar to the merge interval, but it is slightly different actually. So let's just find out how is it different. So we are basically having 0, 2 and 1, 5. So if we take the intersection of 0, 2 and 1, 5, it will be 1 and 2, because if we take the maximum of the minimum values and the minimum of the maximum values, it will be 1 and 2. Now, before actually going to the second iteration, which is 5, 1 and 8, 12, we actually also having an intersection point at 5 and 5, because this point and this point is kind of matching, right? So for that, we basically need to take care of that. This is how this problem is different from the merge interval problem. And here the lists are already given in the sorted order, so we don't have to worry about the sorting of this list. This is sorted, this is also sorted. So I think the best way to solve this problem is to use a merge. Like you might have used the merge sort a lot of time. So the merge part in the merge sort is actually can be applied here. Let's see how. So I am kind of writing this list down, or let me just take another example for simpler example for that understand. Let's say I am having my list something like 1, 2, and then I am having second element as 5 and 10, and then I am having third element which is 12 to 16, right? Now let's just say we have another list which is from 1 to 5, and then we have second element from 7 to 12 or 7 to 11. Just make it 11. 7 to 11. And the third element is basically from 13 to 16. Right? So if we take a look at it, this is actually fine. Don't get confused. So if we kind of draw this onto our horizontal line, let's say this is our horizontal line, this is 0, and this is whatever is the last point possible, 20. And let's say we divide this into 5 intervals. So this is 5, this is not 5, this is 3, see, this is 6, this is 9, this is 12, this is 15, 18, something like that. So I'm just drawing it roughly just to show you the example. So let's just try to draw each of these in different colors. So this is A and this is my B, right? So this is my A. So basically when A starts from 1 to 2, so let's start from 1 to 2. 2 will be here approximately. So this is A, and now B starts from, let's first do A. So now another A starts from 5 to 10. So this will be here 5 to 10. And then the third part of the list, third interval in the A list will start from 12 to 16. So this is my third interval. Right. Now let's do list B. So list B will start from 1 to 5. So it will be from 1 to 5. Right. And then second part of B will be from 7 to, so 7 is here. From 7 to 11 it will go. Right. And then the third part of list B will go from 13 to 16. So from here to almost here. Right. Let's move the extra part. Right. So if we take a look at the intersecting intervals, this is the intersecting interval between these two lists. So this and this is intersecting. So up here it was 1 and here it was 2. Right. And similarly for this case, this intersecting minutely at this point, and then there is a whole lot of intersection from this part to this part. So this is the intersection part. So if we take a look at this point is 5 and this point is 10. And so this point was, I think, 7 and this point was 11. Right. So there is intersection at 1 and 2. There is intersection at point 5, which is a point intersection, and then there is range intersection from 6 to 10. And then similarly we are having an intersection from this point to this point. This is a range intersection, I would say. So actually these two are the same. I don't know why my time is not drawing straight line. So this actually starts from 13 and go to 16. And then we also know, so these are the intersection points that we have. So if I'll have to write the answer for this problem, it will be 1, 2, and then we are having at 5, and then we are having at, so this starts from 6, right? No, this starts from 7. So this is point number 7. So from 7 to 10 we had, and then our next intersection point start from 13 to 16. So I think this would be the solution for this particular problem. And the best way to do it, if you look at it, is that, so if we are at 2, right, and this is 5, that means this interval, overall interval, is smaller than this interval, B interval. So we increase this and we move to this interval, right? If you just follow with me, and this is similar to the merge part of the merge sort algorithm that we have. So in the merge part, remember we basically have two loops, 2 pointers, I pointer and J pointer, which are iterating over 2 collections of 2 arrays. So array A and array B. So whatever is the minimum, we actually take that element and we increase that pointer, I plus 1. So let's say the element for A is less than the element at B, element of j at b, then we increase I by 1. Similarly, if the jth element in b is greater than the ith element in a, we increase j by 1, right? And this will go till we have elements in a, I and j, right? So we are kind of using the same algorithm or same approach here. So let's just see how we can do it. So let me just take another example, or let me just remove it here and continue doing it here. So basically what I'm saying is, so let's say we have two pointers, pointer k and pointer l. So point l, right? So k pointer is iterating to a and l pointer is iterating to b, right? So now we basically take the minimum of, so initially both k and l are 0. So k, sorry, this is going to be a problem. Different color, k and l are 0 initially. So both are 0 initially because both will be at the first position initially, and then what I will do is I will compare this part, the right part of each of the element of k and l. If the right part is greater for first list or a list here, I will increase the k pointer. If the right part is greater for b list, then I will increase the b pointer. So let's just, this is how it will work. So basically we have I and j. So we will always take this minimum of minimum of the last two element, or let me just, so we basically our interval will be, our interval will always be like, so this is my interval, and here we will be having maximum of left 1 and left 2. So basically the left part of a and b interval, so here 1 and 1 and comma, so this will be minimum of sorry on that, so minimum of right 1 and right 2. So left is basically the left part of the interval, and right is basically the right part of the interval of each of the interval that we have. So this is how we are going to find our intervals. So this will be the merged intervals, and we will simply keep increasing I if our right part of 1 is less than right part of 2. We will increase j if right part of 2 is less than right part of 1. So we are basically not taking care of the left part for deciding which. So let's just write code for this. So initially we are having two pointers I and j equivalent each of the list a and b, right? So now we are having another list which is the output list, in which we will be storing our intervals. So this is the part which I was talking about, which is the merge part of the merge sort algorithm. So we will take it, length of it, and then J will be length of B, and we don't need to actually go beyond A and B, because if any one of the list finished, then the intersection is no longer exist, right? So we just find the left and the right point in each of the list. So A I, and then for B, the left and the right will be B of Z, right? So now if we are having, so now we are having these points. Now we need to just decide which one actually we need to take. So let's just find the x point, which is the maximum of the minimum points of all the list. Here we only have two lists, so A and B, right? And then there is another point, which is the y point, which will be the minimum of the maximum points of A and B. So this will be R. And then since here x will always be smaller than y, because we are given the list in the sorted order, the interval is also in the sorted order. So we keep it like this. If x is less than equal to y, then only we use them into the output list, which is x comma y. And now we need to increase our pointers. So to increase the pointer, if our AR is less than PR, then so if the right of the first list is smaller, then we will increase I, because I is corresponding to the first list. If that is not the case, and the value of the right of the first list and right of the second list is equal to or smaller, then we increase the second list point, right? And at the end, we will simply return the out list. It should work for the most part. Oh, I got a runtime error. A comma L, B comma L, AR, BR, and number 5, and the file. And number 5. I press O. It should be length. What the I'm doing. So actually, this will be 0 for the start. What I'm doing. So this will be 0 for the start, and this will go till the length of each of the list is exhausted. So let's just try to run it. This should work for this now. Yeah, this worked. Let's just submit it. Got accepted. Yeah. Excuse me, guys. My internet is slightly slow. So this is 76% faster, which is pretty cool. So let's just take a look at the solution again to understand why it worked the way it worked, right? So we basically are expected to find the intersection of these two lists. To find the intersection, the first thing is we don't have to worry about if one of the list has finished or end. So if the length of the list are not equal, or let's say one list is smaller than the other list, then we can simply just go to the length of the smaller list is exhausted, and that's okay. Second thing is that since we also need to find these points where there is a point intersection or only a single point is kind of common, so we came to know that will have to use two pointers, and for each of the pointers we will have to kind of increase the pointer which is has smaller value, right? So This will be kind of step-by-step way. Just the way the merge part of the merge sort works, right? If that would not be the case, then we can simply zip, or we can simply just go on and find the intersection. The easiest case would be when the length of both of these are equal. We would have just zipped these two lists and just use this formula to find the intersection point. But slightly complicated than that. So that's why we'll have to utilize the merge part. So again, yeah, the time and space complexity for this solution would be since this loop will go till the length of the smaller list. So let's say my smaller list is n m are the list. So whatever is the smaller, it will go. The worst case will be when both of these lengths are equal. So in that case, it will be of m or n, whatever. And yeah, there will be a space because we are storing the data output list. So space will also be equal to the length of the space will actually be larger than the length of the smaller list. So you can say maximum it could go to n plus m. In some case, I guess, the space complexity. So yeah, that's the performance of this solution. I hope you enjoyed it. Don't forget to like and subscribe. I'll see you all in the next video. Stay safe. Bye.